next topic in this series is generation. The system generation is the process of customizing an operating system for a specific computer setup. We know no two machines are the same. Some may have more RAM, others may have special hardware like sensors or GPUs and so on. So the system generation lets the operating system adapt by including only the features we need. It's like tailoring a suit to fit just right, trimming away what is unnecessary and focusing on what our machine really needs. Especially in embedded systems and servers, this makes the operating system faster, lighter, and more efficient. So let's jump on to what the system generation is. It's a process of configuring and installing the operating system specifically for a given hardware setup. It's done by choosing and compiling only the necessary modules and the features. And the process is the hardware survey. The hardware is first surveyed to identify the CPU type and see how many processors are there in the system, what type of RAM we do have, what is the capacity of the RAM, what all I/O devices are connected to the system, and so on. And once the survey is done, then we look at the configuration choices, and we choose the features like multi-programming, file system type, scheduling policies and all that, and they are identified for the available hardware best suited. And then it creates a system table, so builds the configuration tables like vector interrupts, device maps and all that. So that tells, so when any device interrupts, then what action should be taken. So there will be tables like interrupt vectors, like each interrupt will have a software that has to be run. Each interrupt will enable a system call or similar, and the interrupt vectors will provide the address where that system call or that part of the code is situated, or it will tell which system call should be used for what type of vectors and all that. And the device maps, something like the device will work only when proper drivers are set. So whenever the system is being activated, it identifies the various devices connected to that, and then creates a map that which device has a what type of driver and where it is situated in the memory and all that. Once the system tables are generated, then the kernel is compiled and it assembles the selected modules into one kernel binary. So it usually is not a single entity. For each of these individual systems, there will be different modules, and depending on what is required, that has to be used. So for example, if we are talking about a keyboard, there are many types of keyboard may be possible. So for every type of keyboard, one driver will be put into the operating system, but it's not necessary to have all the drivers actively participating, because it requires only the corresponding driver for the current keyboard being used. So when it's being installed, the operating system, the hardware is surveyed, and then it just identifies what type of keyboard we have, and then looks back into the back end and see in the drivers list which driver is most suited for the current hardware we are using, and only that component is selected, only that module is selected. So that way, for all possible situations, like what type of RAM we have, what IO devices we have, for everything there will be a module, and these corresponding modules only are selected, and then all these are dumped together, and one kernel library or one kernel binary is created, and finally it's installed. So this whole compiled operating system is copied onto the boot media. So what boot media is, what booting is what is the discussion of the next session. So in all, we have a variety of various device possibilities that are to be connected. So today it's era of plug and play, so we don't have to have everything built in the system itself. We can plug and play with any of the devices like keyboard, mouse, hard drive, any maybe a PlayStation or any such thing can be just connected to the system through the ports available, and that has to be automatically recognized and made to work. So to make any device work, appropriate drivers are required, and most of the drivers are bundled up under the driver part of the operating system. But we are not interested in every driver. Whichever module is to be used, depending on what hardware we are working with, what mouse we have, what type of keyboard we have, what type of display we have connected, and all that thing. So depending on that, one particular module is required for every situation, and then all those things are selected and bundled up and created as one kernel binary, and this kernel binary is finally compiled onto the boot media. So that's the work done by the system generation part of the operating system. Yeah, of course, the confusion is the boot media, what boot media is all about. So that's what we are going to look at our next session. So please don't miss the next session. It's the most important part of operating system, that is the bootstrap booting. That is how the operating system gets loaded onto the system. So that's it for this session. So please do like, subscribe and share with your friends, and press the bell icon to get the notifications as and when new episodes are released. So keep watching. Thank you.